Hey guys, this is Mark Carrion. We're going to go through the carbon cycle. This will be part one of a video on the carbon cycle itself. A couple of things we're going to go through here, and let me move that. Um, when you look at the carbon cycle, we really have to start off by talking about photosynthesis and respiration. So photosynthesis, if you remember, is CO2 plus water plus energy, which is coming from the sun, and that's going to yield glucose and oxygen. Okay. And plants go through photosynthesis. They take in sunlight, carbon dioxide from us and the atmosphere, and water that we give them. The reverse of that is aerobic or cellular respiration, as you guys probably know it better from ninth grade. That's where we have the opposite happening, the reverse. Glucose plus oxygen makes CO2 plus water, and we put out energy when we're breathing. And so if you can accelerate that respiration by exercising, you'll give off more energy. And that's the burning calories that we talked about in unit one of this year, the very beginning of fall semester. When you look at an energy diagram of this, you notice that if we're going in this direction, we're looking at cellular respiration, and we start with the glucose up here, the oxygen there, and it's downhill to get to CO2 and H2O, which, if you remember from last unit, exothermic means downhill on an energy diagram for that. So that's one way to look at the energy diagram. If we look at it in reverse, now we're looking at going backwards, going this way, and you have photosynthesis. So CO2 plus water, we put energy in, we end up with glucose and oxygen. It's endothermic because the delta H that we talked about last unit is positive. Okay, that change in energy or delta H is a positive value. Don't worry about the bump here. That's activation energy, and we haven't discussed that. So that's just the energy to get a reaction started. And so when you're going the exothermic direction, you have to put a little bit of energy in, but then it's, downhill from there. Okay. So, but don't worry about that right now. All right. So let's go to the next part here. And let's look at this. So what you saw in those equations is summed up in these bullet points. And so we have photosynthesis, which is shown in the first bullet, and it says it's an endothermic reaction that produces glucose and oxygen in plants. And then the second part of what we talked about is the animals, eating the plants, and through exothermic cellular respiration or aerobic respiration, they give off CO2 and water. And the carbon cycle is shown, down below here. And you can see how things operate here. The sun's going into the plants. You get photosynthesis, you get glucose and oxygen. Animals eat the plants. You get, I don't know why a chihuahua's eating a tree. You get cellular respiration, which makes carbon dioxide and water, which goes back into the plants. And with that happening, we end up with a cycle. That brings us to combustion of hydrocarbons. And so with the combustion of hydrocarbons, we have this, and we're looking at hydrocarbons, and those are substances made of carbon, hydrogen, and sometimes oxygen. So we have some examples here. We have methane, which is natural gas. We have propane, which is a gas that you might use if you're out in the country. You have a propane tank that helps heat your water, and or if you have a propane stove in your kitchen. Methane is used more in town, where we have natural gas that's coming into each home for hot water heaters and for stoves if you have a gas stove. Glucose is the energy that we operate off of from the food that we eat. And just to review, remember that combustion or burning of a hydrocarbon always produces these two things, CO2 and H2O. And so we have our equation here of CH4 plus 2O2 gives us 2 waters, 1 mole of carbon dioxide, and energy that's given off as we burn that stuff. So hydrocarbons, as far as the gas ones, those are coming out of the ground. We mine it. We also, can mine liquid type hydrocarbons like petroleum. And so it's often good to know, where and how does oil form, okay, for that. And so we have, let me just put this, whoops. So we have the steps here for how oil forms. And let me just get you to this picture. When you look at this, it shows the steps here on the left, and it says dead plankton sinks to the ocean floor and mixes with sediments and mud. So in the ocean itself, plankton, the plant life is dying, falls to the ground or to the bottom of the ocean, I should say, and it starts to mix with the sediments, the sand, and the mud that are down at the bottom of the ocean. Okay, becomes sapropel, and younger sapropel is just the beginning stages of the hydrocarbons forming. And so younger sediment, new sand and mud piles on top of it. Well, whenever you get that increase of stuff on top of it, it increases the pressure. Kind of think of being in a swimming pool. When you're in a swimming pool, if you go down to the bottom of the pool, there's more water on top of you, which creates more pressure. Okay. And so that happens there. Well, when the pressure goes up, the temperature also goes up. And so you end up with the temperature rising. And when it gets to 50 degrees Celsius, it converts to something called kerogen, which is a solid mix of different organic compounds that are coming from that dead plankton and the mix of the mud and everything together. And this is a long process. This is a very slow process. On the diagram, it says 100 plus years, but we're looking at really, thousands to millions of years for this to happen. This stuff all gets folded into more sediment. So think of baking. For making chocolate chip cookies, which my wife and sons did last night, actually, you've got the dough and you got to fold those chocolate chips in. And so you get them folded in and mixed in there. And that happens with the kerogen. It gets folded into more sediment layers. And as the pressure keeps increasing, the temperature keeps going up. They're 1-to-1. And so it gets up to about 80 to 120 degrees Celsius, and it converts into liquid petroleum. And so that's how we get our oil that we have in reserve. Now, a couple of things. Most of that oil is forming under the ocean, on the ocean, or under the ocean floor, I should say. But you notice that we still, we drill for oil here in California, in Bakersfield. If you go down there, there's oil wells in Texas. So how did the oil get there? Well, as tectonic plates move, the oil stays stationary in some of those cases, and the tectonic plate moves over the top of that deposit of oil, and then they can, drill it out of the ground. There's also offshore drilling. There's pluses and minuses to that, a lot of minuses to offshore drilling. We'll look at some of that when we get into fracking in another set of notes, okay, and talk about that. So that's how the oil, is able to be drilled, over land masses like Texas and California. So fossil fuels, it's a term that we use a lot. Fossil fuels include petroleum, which is our oil that we just talked about, the natural gas that we looked at with the combustion of hydrocarbons, and coal. Okay. It is believed that the burning of fossil fuels contributes to the growing amount of CO2 in our atmosphere. So as we burn fossil fuels, let's go back to this. Remember, we get CO2 when we burn fossil fuels. So as we look at that, we have a growing increase of CO2. And we're going to look at some data in this video just to show how that's operating. California no longer uses coal to produce electricity. So we asked the question, what are some replacements we use in California since closing down the last coal plant in 2015? So there, you guys can probably think of some of these replacements. We have wind. If you go towards the Bay Area, you'll see a lot of wind machines out there. You look at the homes here in our town and other cities in California, we've gone to solar. So there's a lot of different ways of replacing the coal. A lot of our energy comes from nuclear, especially here in Madeira. And we've got 4 operating nuclear power plants, total of 5. One never opened, but we've got 4 nuclear power plants in operation to give us electricity. Nuclear is relatively clean as far as the atmosphere is concerned. The problem with nuclear, again, is the radioactive waste that's left over. So we're making gains in California. We're one of the cleanest states as far as regulations go. For getting rid of things like that. So no more coal burning in California. with that, we still have an issue with the CO2 levels in the atmosphere. You can see in this graph that it's trending upwards, but it's not just trending upwards. It's trending upwards, but in an exponential way. That meaning the curve is getting steeper as we get into 2020. Why is it trending that way? The idea is that because we're burning more fossil fuels than we did in, say, 1900, when there were still, many horses being used for transportation, because we're burning the fossil fuels, especially in cars that are gas burning. We burn natural gas to make electricity in California, things like that. Cooking, barbecuing, things like that are all contributing to it. And so it's causing it to go up exponentially. It's not just a straight line, increase. How does population increase affect this trend? Well, as our population goes up, obviously we're burning more carbon, or we're burning more fossil fuels, which makes more carbon dioxide, which goes into the air. And with our increased population, it's been tough. Now, as you may have read, as we're in this quarantine time of social distancing, staying at home as much as possible, we're not driving as much. They're talking about ozone layers getting basically healed, for lack of a better term. This may be a bright spot in the staying at home thing, and that it's maybe cleaning up our air a little bit, getting rid of some of the CO2 that we've had, and we'll see how that operates. That'll actually be a nice little laboratory experiment there to see what's going on. So that is part one of the carbon cycle. We're going to get into part two on the next video, and we're going to talk about the biocycle and the geocycle, and we'll also talk about something called a feedback loop and what those are and how they affect what's going on with the carbon cycle. So let me know if you have questions. You can comment in the video below, the page below, or you can comment on Classroom, or message me on Remind if you have questions about this. But this should help you with the problem set on the carbon cycle that was posted to Classroom. Okay, have a good one.